Right? So your domain for all linear functions would be negative infinity to infinity. Always.
For all what?
For all linear functions. For lines. Yes. Do I have a highlighter? Yeah.
Michael, we just picked one.
Sure. What color?
Tell me.
Blue.
Oh, you didn't get the picture?
She gave. You said you didn't care. Take it over her.
Did you not wear your pink shoes? But Shay and my dad said they were both pink. They're definitely purple.
Okay. It doesn't matter. Right? So domain for linear functions, right? Which makes sense. Right? They extend infinitely to both infinities. There's no holes or gaps or anything funny, right?
No funny business.
No funny business with linear things. None. That was a very serious face, Savannah. Okay, same thing for the range, right? For linear functions, it's going to be negative infinity to infinity.
Linear is just so easy.
It is.
Man, I'm so good at this already.
They are the basic building blocks of math.
Almost like this is from 8th grade or something.
This is from 10th grade.
Is it actually?
Oh, is it?
I mean, you do it in 8th grade as well, but...
Too advanced, man.
Okay, so let's talk about constant functions. Right, so that's either when... That's when you've got a horizontal line, right? So what would your domain be? What are the possible x values?
Negative infinity to infinity.
Yes. So your domain would be negative infinity to infinity.
Always?
Because it's always going all the way across, right?
It's always constant.
It's like math.
Yes. But the range, is it going up and down at all? No. So that's why your range, in this case, it's 2 to 2, but it would be wherever it's at. So like if my line was up here at 4, my range would be from 4 to 4. It stays at 4.
Wait. What's that blue dot?
I think they're just...
Is that saying up to over 2 for your range?
No, because it's in brackets.
Okay.
I think they just picked a point on the line. I don't really
You
know.
have to put range in brackets?
Yes.
So wait,
No, like not... If it's a number... If it includes that number, it gets a bracket. If it's like up to that number, but not like including it, it's a parenthesis. Infinity is not a real number, so it gets parentheses. We'll explain it more in a minute, okay? Does that make sense for constant and linear functions? Okay? Again, remember, our domain is all of our possible x values. Range is our y, so we look up and down for range, side to side for domain. So, for absolute value, right, our domain is going to be what?
Negative infinity to infinity.
Negative infinity to infinity, always.
Is this for every single one?
No. If that was the case, I would just be like, it's always this, and we'll move on. No. That's no fun.
Now we don't have to find it.
There's not any funny business.
So the domain's not always the same.
Not always. So far, yes, but it will change.
my ducks are huge.
Same. They're in on and they ate all the goldfish.
No,
How did we get here?
That's a bird.
I'm sorry.
Guys, we've got it.
Okay, I got
Is it plugged in?
No, it's
Isaac?
not. I did that myself.
Why do people... There's literally a whole power strip over there, and people are still plugging into the wall. No, you unplug iPads.
Charger that isn't being used.
Don't unplug my iPad.
That's my iPad, silly.
But my iPad's on the other one.
Is yours?
Yes.
Silly goose?
Guys, focus.
Oh, yeah.
No, you're not. Okay, so for absolute value, your domain is negative infinity to infinity because it's always right. It's always going to extend all the way out, right? Your range, though, it's going to be whatever it starts at, right? So like range, the only y values we have are this one is starting at -1, right? But it's going to go up to infinity. right? But if it was,
Start at negative, or
what? No,
wouldn't it technically start at negative infinity?
no.
No, like a little point.
We're looking up and up, like up and down. We're following because the arrows go like this. It's going up.
I understand this one better.
You're not always reading left to right.
Not for range. No, range is we're thinking up and down. Okay, but what if it was one that looked like this?
Positive 2 to negative infinity.
You have to go the other way. Negative infinity to positive 2.
Because you read it like
Kind of, sort of, yeah.
with the
So just wherever that little vertex is.
Mm-hmm.
Okay. I
Is it
remember.
always like an infinity?
Mm-hmm.
And this is the other one?
Yeah.
So it's
It is
never
for absolute
numbers,
value.
Besides
No.
the last one. The last
Yeah, right. Yeah.
one? Okay.
It's going to be different for every function. There's not an always for all of them.
That's just like the other ones, isn't it? Basically the parent functions.
Yep. All right, so does that make sense for absolute value?
Yeah.
Okay. What's next?
I'm extremely loud.
I'm not voting.
Right, so then, look, we can figure it out just by looking at the equation, right? So this is an absolute value equation. We know that it's going to go up 17, right? Our vertex would be at 0, 17, right? Domain is always all real numbers. The range, then, we know that it's opening up starting at 17, so we can say that that's our range, okay? We don't always have to have the graph. We can figure it out from the function.
So that one's always for that domain too?
Mm-hmm.
Hey, yeah.
so it would be
Be what?
infinity to 17.
17 to infinity. Because it's starting at 17 and going up to infinity.
Would that be negative 17 if it was down?
It's not.
But on your graph, that v would be going down.
Is this on
No, it's
plus
not.
or quad?
V is going up.
Oh,
Oh, because it's plus 7.
Uh-huh.
I was in the wrong thing.
No. If you have a negative in front of this, that's going to make your V go down, right? It's only if it's reflected.
Oh, I gotta draw that little illustration.
If there wasn't a negative sign in the example, then
Right, but I drew another example. For if it was negative.
Yeah.
I'm good. Forgot to use my medicines.
All right.
Hold on, hold on.
So if that's a negative number, it's gonna be, that number is gonna be negative?
Okay. So, quadratic functions, again, always have a domain of negative infinity to infinity.
I love it.
Savannah, does your cup just say corn?
No, it's in corning.
Oh.
Where my dad works.
Oh, okay.
Corning is the
Oh.
one.
That's T.
That's the T.
It's calm.
Makes sense. Okay. Makes more sense than corn anyway. All right. So, huh? I like corn too.
I love corn.
I love corn. It's calm.
Corn.
Honey butter corn. Mexican street corn.
Grilled corn though.
What?
Grilled corn.
I've never had
Chili's
corn.
Mexican.
You never had corn like cooked on a grill?
Never had it.
Like you think honey butter.
Missing out, man. All right. Sorry, did not mean to get us distracted by corn.
But it's calm. It's calm.
I know. Okay. So, do we understand why the domain is negative infinity to infinity?
Yeah.
Okay.
So with domain, you're reading left or yeah, because it's X.
It's X. Range is up and down.
Wait, I know I said that. I don't. Isn't it infinity to infinity? Like positive because it's up there? Like that's positive.
We're thinking this way.
That's negative, that's positive.
Yes.
So we're not considering that domain.
Not for domain.
Not for domain. Okay. Good.
Domain is all of the possible X values.
So you're not thinking about okay, gotcha.
Mm-hmm.
Gotcha.
Now, for the range, right? The lowest possible point we have is going to be lowest or highest, right? It's going to depend, but it's our vertex, right? So to figure out the domain of a quadratic, or the range of a quadratic function, you're going to have to find the vertex.
Yeah, I did that.
Right? Or it's nice and gives it to you, right?
Can you do absolute value domain?
We just did that.
No, but what if it's like a point to a point? You know what I mean? Like
It's not going to be.
it's not gonna be.
No.
So we don't have any of those things.
Not yet. Okay.
What? That was a legitimate question.
Okay. We're on quadratic functions right now, though. Right? So your range is going to depend on your vertex. So for this one, we know it's, you have to think about which way it's opening, right? It's opening up or down? Up, right? So that means that that's going to be the lowest point. Our vertex is the lowest point, right? It's a minimum. So then we know that it starts at whatever that part is of our vertex, the y coordinate. So -4. And it's going to go up to infinity.
What range is lowest or highest point in the
Yeah, so if it say we had a negative x squared here, then it would be negative infinity to whatever that high point is. Okay, but you use the y coordinate of the vertex.
So isn't it the same as absolute value?
Yes.
Huh.
Did you just say you hear flames?
I said fire flames.
Oh.
Fire flame.
Pearson said that. When you find out vertex,
I feel like for these, it gives you the vertex for the most part.
what was it? Is it the negative b? No, that's the
Glowing.
It's when you put it in vertex form. You can use the negative b over 2a and then plug that in. Yeah. Okay. So, radical functions. Those are ones with square roots. Okay?
No, we don't have the negative. I just remembered.
Huh?
We don't have negative.
Nope, this is where it gets different, right? Because, look, there's nothing, you have to think about what's going to make it real or not, right? Can we have a negative under this square root? No, right? So that's going to tell us we need to think about what will
Wait,
make that negative.
technically, couldn't you have a negative if that negative was before the square root?
All right, but we're not dealing with that. Oh, no. I mean, if it's a negative and then a square root, yes. If it's a negative under a square root, no.
So these aren't always going to be one thing?
Huh?
These aren't always going to be one thing?
What do you mean by one thing?
Like,
Wait,
a lot of these are like,
They won't be negative infinity to infinity.
no.
wait, what?
Well, because like we have like all of the linear.
Yeah, these will be different depending on what you have. I'm with you now.
What class is after this?
5th period.
What's our fifth period? That sounds a whole lot like
Why
ours.
is it
Feels
one?
weird
Because you
just
have
because
it
you
to forget.
I'm gonna take a nap, my truck.
But look.
Okay, guys, we've got to get through this.
I'm so prepared. Let's get it.
Okay. So let's look at the example on the next page, right? But looking at the graph, do we understand what's happening?
Yeah.
So it starts at, let's think domain. It starts at 1. So it starts at 1 and just, it keeps going to infinity, right?
Oh, that's the main. Oh.
Okay, range. It's starting at 1, 2, 3
There it is.
and going to infinity, right? So looking at the graph, it's pretty straightforward. Okay?
When we're looking at the function, though, what do we have to do to?
That's what's next.
Oh.
It's on the next page. That's why I'm kind of... All right, we good here?
Yes, ma'am.
So then looking at the function,
Oh yeah. That one's hefty.
so to find the domain, you want to take what's inside the square root and set it greater than or equal to 0, because it has to be greater than or equal to 0. It has to be positive, right? So then we solve that. So that means our x value has to be bigger than -4.
Oh, so it's always gonna work.
So that's going to give us the part of our domain that we need.
Is it always gonna work with it?
Yes.
Okay. I like this because like.
All right, we're just finding the domain right now. Domain's going to deal with what's inside. Range is, remember, when you add stuff on the outside of anything, that's going to shift your up and down. Yeah, so that's where your range is going to come in. Good question, though. Okay, so then for the range, so it's going to start wherever whatever's being added or subtracted outside. Okay, so you've got your -5. But it's going to depend. So if it was, we have this negative here that we have to consider, right? So that means our graph is going to be something more like this. So that means we're going to start at, yeah, so it comes up from -infinity and goes to -5. So if that was positive, it would be -5 to +infinity. The negative switches it. Yep. Make sense?
So you
Wow.
change that sign, but you're not changing the sign
Well, the
this
reason-
time.
All right, swoosh.
I apologize.
Too many of you at once.
So you would change the sign.
You wouldn't
But-
change the sign. You would change the infinity sign and switch them if it was positive. Okay, let's do B. I think that'll make more sense, okay? All right, so starting with the domain. Take what's under the square root, set it greater than or equal to 0. Subtract your 7. Divide by -1. When you're dividing by a negative, you flip that inequality. So that means that x is everything less than 7, right? So that means we're going to go from -infinity up to 7.
Yeah.
Okay. Because everything has to be smaller than -7. So we want to start at 7 and go down for the domain.
Yeah.
If you end up having to flip it, if it's less than, it's -infinity. If it's greater than, it's positive.
But how do you know to flip it?
Because I'm dividing by a -1. Anytime you divide by a negative, you flip the inequality sign.
Gotcha.
Okay? And then the range, we're looking at this 2 right here. And so since there's not a negative in front, it's just -2 to infinity.
Why don't you do the bracket thing?
Oh, I meant to.
Oh. Brackets for real? Parentheses for
Yeah, I like this better because there's more like stuff that you can actually believe in
I'm
instead of just like guess. I mean, you know, usually with math, it's like sometimes you do this, and for most of these, it's just like, yeah, dude, you're always doing that.
I mean, okay.
It's good, you know what I mean? I have like something to believe in here, like something to trust in.
something to believe.
dumb.
This is 2000. This is not a pen from 2003. Maybe it is. That'd be hilarious.
Silly goose.
Japanese. Why did you get 2 fucking grades?
Didn't this class end at 25?
35.
35. I was wondering what time.
Okay, let's go ahead and pause there for the notes part. We are going to do some of these problems.
Of what variety?
All right, so let's look at the packet. Yeah, 1 through 30.
Oh, they're in the packet.
Mm-hmm.
Sorry, I know you said
That's
that.
neat.
Yep.
So tomorrow you're going over the rest of them?
Yeah.
Oh.
I don't know. I might give you guys time just to work through these tomorrow. That's probably what I'll do.
Are you gonna make us do work for something?
All of you are going to be gone, right? Then yes. Then no. Like. All right. Go ahead and start working through 1 through 30. It's not homework, but we've got time, so get started. Those are just through the ones we did today. We'll talk about the rational ones tomorrow. They're